High in the thin air of the Andes, where condors soar over peaks that scrape the sky, an empire once moved with a rhythm and precision that defies belief. Stretching for more than 25,000 miles, a distance greater than the entire circumference of our planet, a web of roads bound together the largest empire in the pre-Columbian Americas. This was the Qhapaq Ñan, the royal road of the Incas. But here is the fact that should stop you in your tracks. This monumental achievement, a network that rivals the famed roads of ancient Rome, was accomplished without two technologies we consider fundamental to any great civilization: the wheel and a system of written language. How could a people using only stone, bronze, and Bronze Age tools conquer some of the most treacherous terrain on Earth to create a highway system that stuns engineers to this day? The answer lies not in lost technology, but in a breathtaking mastery of environment, a profound understanding of materials, and an organizational genius that turned mountains into messengers and deserts into destinations. This is not just a story of stones laid upon the earth. It is a story of human ambition on an almost unimaginable scale. The Inca Empire was a place of incredible diversity, encompassing coastal deserts, lush rainforests, and the unforgiving high plains of the Altiplano. To rule this vast and varied territory, the Qhapaq Inca, the divine emperor, needed a circulatory system for his empire, a way to move armies, relay information, and transport goods with speed and reliability. The roads they built were the lifelines that made the empire possible, allowing a message to travel from the capital of Cusco to the farthest reaches, a distance of over 1,200 miles in less than a week. Imagine a runner, a chasqui, waiting in a small stone hut, hearing the distinct blast of a quipu-tied shell trumpet echo from the previous station. He would sprint out, take the verbal message or the knotted string quipu recording vital information, and then run to the next post, his breath visible in the frigid mountain air. This was a system alive with human energy, a testament to what can be achieved when a society mobilizes its collective will toward a single, magnificent goal. So today, we are going to walk these ancient paths together. We will journey beyond the famous sites like Machu Picchu to uncover the true marvels of Inca engineering hidden in plain sight. We will see how they built suspension bridges from woven grass that could withstand the violent gusts of mountain passes, how they carved stairways directly into cliff faces, and how they engineered drainage systems so effective that many sections of the road remain intact after 500 years of neglect. This is a journey into a mystery, a puzzle of stone and human spirit that challenges our modern assumptions about what is possible. We will explore how the Incas didn't just build roads through their world. They built roads that were a part of their world, perfectly integrated into a landscape they both feared and revered. This is the story of the Qhapaq Ñan, and it is one of the greatest untold chapters in the history of human engineering. To truly appreciate the engineering of the roads, we must first grasp the sheer magnitude of the empire they served. This was not a compact kingdom nestled in a single valley. It was a continent-spanning colossus known as Tawantinsuyu, the land of the four quarters. From its bustling capital, Cusco, the empire radiated outward, eventually controlling a territory that stretched for more than 2,500 miles along the spine of the Andes. To put that into a modern perspective, this distance is equivalent to the entire span of the continental United States from north to south. Within these vast borders lay some of the most extreme and varied geography on the planet. The Incas governed everything from the parched, sand-dune coast of the Pacific, up through fertile river valleys, into the breathtaking but oxygen-thin altitudes of the high Andes, where peaks rise above 20,000 feet, and down the eastern slopes into the dense, steamy Amazonian rainforest. This incredible diversity presented a monumental challenge. How do you maintain a cohesive, centralized state across landscapes that range from arid desert to frozen tundra to impenetrable jungle? The answer was the Qhapaq Ñan, The road system was not a luxury or a simple convenience. It was the absolute, non-negotiable backbone of imperial power. Without it, Tawantinsuyu would have been an impossible concept, just a collection of disparate valleys and tribes. The roads functioned as the empire's central nervous system. Along them moved the imperial army, the most powerful military force in the Americas, allowing the Qhapaq Inca to project his authority to the farthest corners of his domain and quell rebellions with stunning speed. But it was more than just a military highway. These roads were the vital arteries for trade and tribute. Goods flowed along them in a constant stream. Dried fish and precious spondylus shells from the coast, fine textiles and dried potatoes from the highlands, exotic feathers and medicinal plants from the jungle. All of this wealth was funneled back to Cusco to support the nobility, the state religion, and the vast labor force that built the empire's monuments. Perhaps the most critical function of the road, however, was communication. In an age without writing, without horses, and without wheeled carts, information was the most precious commodity of all. The Incas developed a solution of elegant simplicity and remarkable efficiency, the chasqui relay system. Picture a series of small, stone-built tambos or waystations, spaced at intervals of about 1 to 2 miles along the road, a distance a fit runner could cover at a sprint in the thin mountain air. Inside each tambo, 2 or more chasquis, highly trained and conditioned from youth, waited on constant alert. When a runner approached from the previous station, he would blow a conch shell trumpet, signaling his arrival. The waiting chasqui would run out to meet him, receive the memorized oral message or the physical quipu, a complex record-keeping device made of knotted cords, and then immediately set off at a full run towards the next station. In this relay fashion, a message could travel an astonishing 250 miles in a single 24-hour period. This meant that an order from the emperor in Cusco could reach a governor in distant Quito, over 1,200 miles away, in less than a week. This system gave the Inca state a speed of information that would not be surpassed in the region until the invention of the telegraph centuries later. It was this ability to communicate and react faster than any potential rival that made the empire not just large, but truly unified and incredibly resilient. The road was the physical manifestation of that control, a line of sight and power carved directly into the face of a continent. Now, when we say this was a road network, it's vital to move beyond the image of simple dirt trails. This was a formally constructed, state-sponsored infrastructure project of staggering complexity. The system was anchored by 2 magnificent primary highways, acting as the main arteries from which countless smaller roads branched out like veins and capillaries to connect every province, every mine, and every temple. The first and most famous of these was the Tawantinsuyu Road, often called the Highland Road or the true Qhapaq Ñan. This was the engineering crown jewel, a breathtaking feat that ran the entire length of the empire along the spine of the Andes Mountains. Imagine a highway carved directly into the sides of precipitous cliffs, snaking through high-altitude passes over 15,000 feet above sea level, where the air is so thin that unacclimated travelers can barely catch their breath. This road connected the major highland cities from Cusco south to Lake Titicaca and onward into what is now Bolivia and Argentina. Its path was chosen for strategic control, offering unparalleled views and minimizing the threat of ambush, but it demanded extraordinary engineering solutions to tame the raw power of the mountain terrain. Running parallel to this along the Pacific coast was the second Great Trunk Road, the Tawantinsuyu Road or Coastal Road. While perhaps less visually dramatic than its highland counterpart, its construction was no less impressive. It had to navigate a completely different set of challenges: vast, waterless deserts where the sun was relentless, shifting sand dunes that could swallow a path overnight, and fertile river valleys that required frequent crossings. The builders of this road constructed long, raised causeways to keep travelers above the floodplains and used walls to mark the route across featureless stretches of sand. Where the two great roads needed to connect, to move people and goods from the coast up to the highlands or vice versa, the Incas engineered a series of lateral roads that crossed the Andes like the rungs of a ladder. These connector roads were often the most difficult to build, plummeting down deep canyons and scaling opposing mountain walls in a series of relentless switchbacks. The logistics of maintaining this 25,000-mile web are almost beyond comprehension. Think of the constant upkeep required. A landslide in the high mountains could wipe out a section of road in an instant. A flash flood in a desert gully could scour away a bridge's foundation. To address this, the empire institutionalized a form of labor tax known as the mitta. Every household across Tawantinsuyu owed a certain number of days each year to work on state projects, and maintaining the road was a primary duty. This meant there was, in theory, a rotating workforce dispersed along the entire network, ready to repair damage, clear debris, and keep the way open. This system transformed infrastructure maintenance from a monumental, sporadic burden into a manageable, continuous process woven into the very fabric of Inca society. The road was not a static monument. It was a living, breathing entity that required the collective effort of the entire empire to keep its heartbeat strong. But building such a vast and durable network first required solving an even more fundamental puzzle: where to place the road. Before a single stone was set, Inca engineers faced the monumental task of plotting a course across a continent of geological chaos. Without theodolite's GPS or even detailed maps as we know them, their approach to surveying was a blend of profound environmental intuition and sophisticated observation. They likely began not with complex calculations, but by walking the land. Teams of specialists, perhaps drawn from the class of wise men known as amateurs, would have traversed potential routes for months, learning the landscape with an intimacy we can scarcely imagine today. They weren't just looking for the shortest distance between 2 points. They were seeking the path of least resistance over the very long term, a route that would remain stable for generations. This meant paying close attention to the subtlest of clues, the types of plants that indicated firm, well-drained soil, the lay of the rock strata that suggested stable versus landslide-prone slopes, and the paths of animals who instinctively knew the safest ways across difficult terrain. A key principle guiding their choices was an almost sacred respect for water. Inca engineers were master hydrologists. They understood that water was both the greatest creator and destroyer of paths. So, when planning a route across a mountainside, they would carefully study the watershed. They consistently chose to build on the drier, sun-facing slopes known as Quechua, which experienced less frost and erosion rather than the wetter, shadowed Sunni slopes. They also avoided building directly at the bottom of valleys or in the beds of dry riverbeds called quebradas, which could transform into violent torrents during a sudden storm. Instead, the road was often positioned strategically on a natural contour line, a kind of spine on the mountainside high enough to be safe from flooding but low enough to avoid the worst of the wind and cold at the highest peaks. This careful placement is a primary reason why so many sections of the road have survived centuries of Andean weather. They were built in the right place to begin with. Beyond pure practicality, there is strong evidence that spiritual and astronomical considerations shaped the road's path. The Incas saw their empire as a sacred landscape, a living being called a pacha. Mountains were apus, powerful gods, and rivers were life-giving spirits. It is believed that certain stretches of the Qhapaq Ñan were deliberately aligned to point toward sacred peaks, like the majestic Mount Osangate near Cusco, or to frame the rising sun on significant dates like the June solstice. These celestial and geographical alignments would have transformed a practical journey into a spiritual pilgrimage, integrating the infrastructure of the state with the cosmology of its people. The road didn't just connect cities, it connected the people to their gods, making every official who traveled it a participant in a sacred geography. This fusion of the practical and the spiritual is a hallmark of Inca engineering. The road was never just a tool. It was a statement of harmony between humanity and the cosmos. The result of this meticulous planning was a route that appears to defy logic yet proves incredibly efficient. Instead of fighting the landscape, the Incas worked with its grain. You can see this clearly in the famous zigzag patterns the road makes when ascending or descending a steep mountain face. These switchbacks are not random. They are a deliberate engineering solution to reduce the gradient, making the climb manageable for pedestrians and llama caravans while also minimizing erosion. On flat, open terrain like the Altiplano, the road often becomes perfectly straight for miles, allowing for rapid travel. But when confronted with an obstacle, the Inca response was typically one of minimum intervention. If a massive, immovable boulder stood in the way, they would simply curve the road around it. If a cliff face was too sheer to go around, they would cut a narrow staircase directly into the living rock. This flexibility demonstrates a deep understanding that the most durable path is often the one that imposes the least on the environment. A lesson in sustainable engineering that feels remarkably modern. The genius of the Inca surveyor lay not in overpowering nature, but in listening to it, learning its secrets, and laying a path that felt as though it had always been there. Once the route was chosen, the real work began, and it is here, on the sheer faces of the Andes, that Inca engineering moves from impressive to almost supernatural. Confronted with slopes that would make a mountain goat hesitate, the builders employed two primary techniques that demonstrate a deep understanding of physics, endurance, and the very stone they worked with. The first was the elegant solution of the switchback. Rather than attempting a brutally direct ascent, which would be impossibly steep and vulnerable to rapid erosion, the engineers designed the road to zigzag gracefully up the mountainside. This series of gentle, alternating turns, known as Andean, when integrated with agricultural terraces, served a brilliant dual purpose. For the traveler, whether a heavily laden llama caravan or a sprinting chasqui, the switchback reduced the punishing angle of the climb into a manageable, sustained effort. But just as importantly, for the road itself, this design drastically slowed the destructive force of rainwater. A straight path down a slope acts like a channel, gathering water and velocity as it flows, quickly carving a deep gully and washing the road away. The zigzag pattern, however, interrupts this flow. Water is forced to change direction constantly, losing its energy and dispersing harmlessly across a wider area. This simple, observant design gave the roads a resilience that has allowed them to endure for centuries. Yet, there were places where even a switchback was not enough, where the terrain presented a vertical wall of rock or an impossibly narrow ledge. In these moments, the Inca response was one of breathtaking directness. They carved stairways, but these were not mere footholds hacked into the stone. They were formal, enduring staircases meticulously engineered directly into the bedrock. Using stone hammers and bronze chisels, workers would painstakingly peck away at the granite or andesite, creating steps that were often perfectly uniform and sometimes accompanied by a drainage channel running alongside. The precision of this work is staggering. In many places, the stairs are seamlessly integrated into the natural contours of the rock, as if the mountain itself had decided to provide a pathway. This technique was used to navigate the most extreme sections, such as the dizzying pass of Waystations or Dead Woman's Pass, on the trail to Machu Picchu, where a seemingly endless stone staircase ascends into the clouds. For the Inca traveler, these steps provided secure footing on otherwise treacherous terrain. For the empire, they represented an unyielding assertion of control, a declaration that no physical barrier was too great to be overcome by human will and ingenuity. The true genius of these stairways, however, lies in their permanence. While a dirt path on a slope would require constant maintenance and would be reshaped by every rainfall, a staircase carved into the living rock is virtually eternal. It becomes a permanent feature of the landscape. This is why modern hikers on the Inca Trail can walk on the very same steps that messengers and soldiers used 500 years ago. The sensation is profound. You are not walking on a reconstruction or a guess, but on the original infrastructure, your boots touching the same polished hollows worn by countless footsteps over generations. This enduring quality speaks to a long-term vision that is humbling. The Incas were not building for a decade or even a century. They were building for an empire that they believed would last forever, and their engineering reflects that timeless perspective. The mountain stairways are perhaps the most visceral symbol of their philosophy. Instead of trying to conquer the mountain, they sought a partnership with it, using its own immutable strength to create a path that would last as long as the stone itself. But even the most perfectly carved staircase or cleverly routed switchback is useless if it leads to a raging river at the bottom of a deep canyon. For the Inca road system to function as a true network, it had to conquer the chasms that sliced through the Andes. This is where their engineering moves from the impressive to the truly breathtaking. They developed a range of bridging solutions, from simple log crossings to elaborate floating reed barges for lake travel. But their crowning achievement, the solution that inspires both awe and disbelief, was the suspension bridge. The most famous of these, the Great Bridge over the Qhapaq River, was a structure so vital and so magnificent that it became a legend in its own time, a symbol of the empire's ability to bend nature to its will. To understand the genius of these bridges, you must first forget everything you know about modern suspension bridges made of steel and concrete. The Inca version was an organic masterpiece, woven not from metal but from the fibers of nature. The primary material was ichu grass, a tough, resilient bunch grass that grows abundantly on the high Andean plains. The construction process began with the harvesting of this grass, which was then twisted and braided into small cords. These cords were then meticulously woven together by teams of skilled workers into larger ropes, and those ropes were, in turn, twisted into the massive cables that would form the bridge's backbone. The process was one of incremental strength, where the collective power of countless individual grass fibers was harnessed to create a single, monumental cable thicker than a human torso. The finished product was not rigid and unyielding like steel, but possessed a natural flexibility that allowed it to sway and absorb the tremendous forces of wind and the weight of crossing traffic. The true test of engineering, however, came in anchoring these massive grass cables across a chasm. The Incas did not have modern drill rigs or explosive bolts. Their solution was one of elegant stonework. On either side of the river, they constructed massive stone abutments, often taking the form of towering pillars or anchors built directly into the bedrock of the canyon walls. The ends of the grass cables were then looped around huge, strategically placed stone grommets or tied to immense wooden beams that were securely lodged within the stone masonry. The tension in the cables was immense, and the anchors had to be designed to distribute this force over a wide area to prevent the entire structure from pulling itself apart. Once the main cables were secured, a footway of wooden planks or more tightly woven matting was suspended from them, with smaller handrails made from thinner grass ropes installed for stability. The final result was a narrow, swaying pathway hanging hundreds of feet above a roaring river, a crossing that required immense courage and faith in the builder's skill. What makes these bridges even more remarkable is that they were not permanent structures in the way we think of them today. Grass, even when densely woven, degrades over time when exposed to sun, rain, and wind. The Incas understood this fundamental fact of their materials, and instead of fighting it, they incorporated it into their societal rhythm. The maintenance and annual rebuilding of a major suspension bridge was not a chore. It was a sacred community ritual, a minka, or collective labor obligation that reinforced social bonds and underscored the bridge's vital importance. Each year, communities from the surrounding villages would gather for the rebuilding ceremony. The old bridge would be cut down, often ceremonially, and its components allowed to fall into the river below. Then, under the direction of master bridge builders who possessed the knowledge passed down through generations, the entire community would work together to weave the new cables and hoist them into place. This event was accompanied by festivals, prayers, and offerings to the Ipus, the mountain gods, and to the river spirit itself, asking for protection and strength for the new structure. This cyclical act of creation and renewal was a profound expression of the Inca worldview. The bridge was not a static object to be built and forgotten. It was a living entity that required the continuous care and participation of the people it served. Its strength was a direct reflection of the strength and cohesion of the community. This stands in stark contrast to our modern approach of building infrastructure meant to last for decades with minimal intervention. The Inca method ensured that the knowledge of bridge building was never lost, as it was practiced and taught anew every single year. It also created a powerful, tangible connection between the people and the infrastructure that made their lives and their empire possible. To cross one of these great grass bridges was to place your trust not just in the engineering, but in your neighbors, your family, and the collective spirit of your people. It was a physical manifestation of the social contract that held Tawantinsuyu together. To truly grasp the strength of these organic marvels, we need to understand the material itself. The primary grass used was ichu, a hardy bunch grass that thrives in the harsh, high-altitude conditions of the Andes. This wasn't a soft, delicate plant. It was a survivor, evolved to withstand scorching sun, freezing nights, and relentless wind. The Incas harnessed this inherent toughness. The process began with communities harvesting the long, resilient stalks. These were then carefully dried, a crucial step that prevented rot and increased tensile strength. The real magic, however, lay in the weaving, a skill honed over generations. Artisans would start by twisting small handfuls of grass into thin, strong cords. These cords were then meticulously braided together into larger ropes. Finally, multiple of these ropes were twisted in the opposite direction to form the main cables. This counter-twisting technique is a fundamental principle of rope making, as it locks the fibers together, creating a structure where the tension and friction between the individual grass blades distribute weight and stress evenly across the entire cable. It was a process of incremental strength where the collective power of countless fragile blades was harnessed to create something monumentally powerful. The ultimate test of this engineering came not from the Incas themselves, but from their conquerors. Spanish chroniclers in the 16th century wrote with a mixture of terror and awe about crossing these bridges. They recorded that the great grass cables, often as thick as a man's body, were strong enough to support not just columns of Inca soldiers and llama trains, but the full weight of Spanish cavalry, armored conquistadors on horseback. Imagine the sight, a line of horses clad in steel, their iron-shod hooves clattering on a wooden walkway that swayed and bounced hundreds of feet above a roaring river, the entire structure groaning and creaking like a living thing. For the Spanish, raised on the solid stone bridges of Europe, this must have been a harrowing experience, a leap of faith into a technology they could scarcely comprehend. That these organic structures held under such demanding conditions is a stunning testament to the effectiveness of the Incas' fiber-based engineering. It proves that the strength of the bridge was not a myth or an exaggeration, but a calculated and reliable feat of material science. This knowledge was not written down in manuals, but lived in the hands and minds of the master bridge builders, the quipu-tied or other specialized artisans. The techniques were passed down orally and through practical apprenticeship, a guild-like system where young men would learn the precise methods of twisting, braiding, and anchoring. The annual rebuilding ceremony was the ultimate classroom. It was during this community-wide event that the subtle nuances of the craft were transmitted: how to judge the correct tension, how to identify the perfect dryness of the grass, how to tie the specific knots that would hold under immense strain. This ensured that the intellectual capital of bridge building remained a vibrant, living tradition, deeply embedded in the culture. The survival of the bridge depended directly on the survival of the knowledge, creating a powerful incentive for each generation to master and preserve these complex skills. It was a system where engineering and cultural continuity were one and the same, ensuring that the lifelines of the empire would pulse with life for as long as the people remembered how to weave the grass of their ancestors. Yet even the masterful suspension bridges had their limits. For the very deepest, most vertiginous gorges, where the walls plunged straight down for thousands of feet and the roar of a river was a distant echo, building any kind of bridge foundation was simply impossible. The winds in these chasms could be ferocious and the distance too great for their grass cables to span, but for the Incas, an obstacle was merely an invitation for innovation. When a bridge wouldn't do, they took to the air, developing a system that must have felt like pure magic. The oroya, a breathtaking cable car system that turned impassable gaps into a momentary, swinging journey. The principle was one of beautiful simplicity. Imagine standing on the edge of a canyon so deep the bottom is lost in shadow. Stretching across the abyss is a single, thick rope woven from the same resilient ichu grass used for the great bridges. This rope, the core of the oroya, was anchored on both sides with the same meticulous stonework, creating a sturdy aerial pathway. But instead of a walkway, the system used a large, sturdy basket or seat, often made from leather or woven leather strips, which was suspended from the main cable by a wooden or leather pulley. The passenger or a load of goods would be placed securely in this basket. On the opposite side of the canyon, a team of operators would then physically pull on auxiliary ropes attached to the basket, hauling it and its cargo across the dizzying void. For the return trip, the process would simply be reversed by the team on the other side. This system showcased an incredible understanding of physics. The main cable wasn't pulled taut in a straight line. It was allowed to form a natural, shallow curve or catenary between the two anchor points. This curve was essential. It meant that the journey wasn't a level pull, but rather began with a descent, using gravity to provide initial momentum, followed by an ascent to the opposite ledge. This cleverly reduced the amount of brute strength needed to move the basket, making the system more efficient. The oroya was not for the faint of heart. To be lowered into a chasm in a swaying leather basket with only the sound of the wind and the creak of the grass rope required immense trust in the technology and the operators. Spanish chroniclers wrote of crossing these oroyas with sheer terror, watching as their horses and supplies were sent across in a similar fashion, the basket swinging precariously over the immense drop. The true brilliance of the oroya, however, lies in what it represents, a perfect example of Inca adaptability. They did not have a one-size-fits-all solution for the challenges of their geography. Instead, they possessed a toolkit of engineering concepts that they could apply as the terrain demanded. For a wide river, they built a stable, permanent-looking bridge. For a narrow but deep crevasse, the oroya was the perfect, minimalist answer. It required far less material than a full bridge and could be installed in locations where construction would have been prohibitively dangerous or time-consuming. This flexibility allowed the road network to maintain its continuity across the most impossible-looking landscapes, ensuring that no canyon, no matter how deep, could truly isolate one part of the empire from another. The oroya was more than just a transport mechanism. It was a statement of relentless connection, a testament to an empire that would not be contained by the very mountains it called home. Of course, the most direct solution to a sheer cliff face was to carve a path directly through it. The Incas were masters of stonework, and their approach to creating stairways showcases this skill in its most functional and enduring form. But this was not a brute force operation. The process began with an intimate understanding of the mountain itself. Quarrying was a careful, selective practice. Rather than simply blasting rock away with gunpowder or modern tools, Inca stonemasons looked for natural fissures and weaknesses in the granite and andesite. They would heat the stone with controlled fires and then rapidly cool it with water, causing it to fracture along desired lines. Using stone hammers made from harder stones like diorite and bronze chisels, they would then work the massive blocks free, a slow, percussive process that required immense patience and precision. The goal was to extract large, manageable blocks that could be shaped with minimal waste, honoring the material they were working with. Once the rough blocks were quarried, the real artistry began. The shaping and fitting of these stones is what gives Inca stairways their legendary durability. The masons would painstakingly dress each block, pecking away at its surface with their stone tools to create flat planes and precise angles. The hallmark of their technique was the concept of ashlar masonry, where each stone is perfectly cut to interlock with its neighbors. For a staircase, this meant that the steps themselves were often massive, single blocks, sometimes weighing several tons, that were meticulously fitted into the prepared bedrock. The joints between these stones are so tight that, famously, you cannot slide a razor blade between them. This incredible precision was not merely for aesthetic appeal, it was a critical engineering decision. By locking the stones together without any mortar, the structure became monolithic. When the ground shifted slightly due to earthquakes, a common occurrence in the Andes, the stones in an Inca staircase could shift and settle together without collapsing, acting as a flexible, unified mass rather than a rigid, brittle construction. The design of these stairways also demonstrated a profound foresight for the greatest threat to any mountain path: water. The Incas understood that if rainwater was allowed to cascade unchecked down a staircase, it would quickly erode the foundation and undermine the entire structure. Their solution was elegantly simple and integrated directly into the construction. Many Inca stairways feature narrow, carefully carved drainage channels running along one or both sides of the steps. These channels were not afterthoughts, they were carved into the stone blocks themselves during the fitting process, creating a permanent, indestructible gutter system. During a rainstorm, water would be captured by these channels and directed away from the vulnerable edges of the staircase, funneling it safely to the side where it could disperse harmlessly down the mountainside. This attention to hydrological management is a key reason why so many of these stairways remain intact and functional centuries after they were built, having successfully weathered countless Andean rainy seasons. Perhaps the most striking aspect of these stone stairways is how they feel less like an imposition on the landscape and more like a natural extension of it. The Incas had an uncanny ability to integrate their architecture into the environment. A staircase would often follow the natural contour of a rock outcrop, with steps that curved organically around existing boulders. In some cases, if a particularly large and immovable rock stood directly in the path, the stonemasons would simply incorporate it into the design, carving steps directly into its surface. This philosophy resulted in structures that appear to grow out of the mountain itself. Walking up a well-preserved Inca staircase, you get the sensation that you are ascending a pathway that was always meant to be there, a feeling of harmony between human intention and the natural world. This seamless integration is the ultimate testament to their engineering philosophy. They were not conquerors of the landscape, but its collaborators, using their profound skill to reveal a path that respected the enduring power of the stone. All of this brilliant routing and construction would have been for nothing, however, if the Incas had not solved the single greatest threat to their roads: water. The Andes are a place of dramatic extremes, where torrential rainy seasons can unleash devastating downpours, turning gentle streams into raging rivers in minutes. An unprotected path on a mountainside would be scoured down to bare bedrock in a single storm. But the Inca engineers were not just road builders, they were master hydrologists who understood that to defeat water, you must first learn to guide it. Their solution was to weave an invisible network of water management features directly into the fabric of the road, a subterranean genius that is the true secret to the Qhapaq Ñan's incredible longevity. The most common and vital of these features was the humble culvert. Scattered along the road, particularly where it crossed a natural drainage channel or a small gully, you will find these clever stone tunnels. They were not complex structures, but their design was flawless. Builders would place two large, flat stones upright to form the walls of the channel, cap them with a third, massive slab as a roof, and then bury the entire assembly just beneath the surface of the road. The genius of the culvert was its simplicity. It allowed water from uphill to flow freely underneath the road rather than over it. This prevented the road surface from being constantly eroded at crossing points and, more importantly, stopped water from gathering on the pathway itself where it could begin its destructive work. These culverts were so effective that many are still fully functional today, silently diverting 500 years of rainwater away from the ancient pavement. On steeper slopes, the challenge was different. Here, water didn't just cross the road, it ran directly down it, gathering speed and destructive power with every inch. To combat this, the Incas engineered a system of drainage canals. These were not ditches dug haphazardly alongside the path. They were formally constructed, stone-lined channels that ran parallel to the road. Often carved directly into the bedrock or built with carefully fitted stones, these canals acted like gutters, intercepting runoff from the mountain above and channeling it safely away from the traveled surface. The placement was strategic. On a causeway raised above the surrounding terrain, the canals would run along the base. On a road cut into a hillside, a canal would be installed on the uphill side to catch water before it ever reached the path. The precision of this system is astonishing. In some sections, you can see how the road is subtly sloped or cambered just a few degrees to gently direct surface water toward these waiting canals, ensuring that even during a downpour, the walking surface remained as dry and stable as possible. Perhaps the most visually impressive hydrological features are the retaining walls. In many places, the road was built onto a steep incline by constructing a massive, terraced wall that held back the earth of the mountain itself. These were not simple piles of rock. They were masterpieces of ashlar masonry, with stones fitted together with that characteristic laser-precise joinery. The structural purpose of these walls was obvious: to create a level, stable foundation for the road, but their hydrological function was just as critical. The Incas understood that the soil behind such a wall could become saturated with water, turning into a heavy, unstable slurry that would eventually burst through. So they built these walls to be permeable. The perfectly tight joints between the stones were counterintuitively the key. Because no mortar was used, these tiny cracks acted as a natural weep system, allowing trapped groundwater to seep through the wall slowly and safely, relieving the hydrostatic pressure that would have doomed a solid, mortared structure. This slow weeping kept the foundation dry and stable, preventing catastrophic collapses. It's a principle still used in modern civil engineering, and the Incas perfected it centuries ago with nothing but stone and impeccable geometry. The cumulative effect of these features, the culverts, the canals, the intelligent walls, was a road that worked in harmony with the water cycle rather than fighting against it. The engineers didn't try to stop the rain. They accepted its power and created a graceful exit strategy for every drop. This philosophy of working with natural forces rather than overpowering them is what separates great engineering from merely brute force construction. It is the reason why, after centuries of abandonment and exposure to some of the most aggressive weather on the planet, long stretches of the Qhapaq Ñan are not only identifiable but are still walkable today. The stones remain in place, the foundations are still firm, because the water that could have destroyed them was never given a chance. The road was designed to survive, and in its silent, enduring stones, we can still read the profound wisdom of the hydrologists who understood that the secret to lasting strength is not to build a fortress, but to build a partner for the relentless elements. So, after navigating the grand solutions of bridges and stairways, let's bring our focus down to the very ground beneath the feet of the ancient travelers. What was it actually like to walk the Qhapaq Ñan? The experience underfoot was far from a simple, beaten path. It was the result of meticulously engineered pavement, tailored with astonishing specificity to the local environment. The Incas understood that a one-size-fits-all approach would fail across an empire of such extreme diversity, so they developed a toolkit of surfacing techniques that varied from the high, rainy mountains to the parched coastal deserts. In the rugged highlands, where water and stability were the primary concerns, the road was often built to last for the ages. The process began not with the surface stones we see today, but with what lies beneath them, a deeply excavated and carefully prepared foundation. Workers would first dig down, sometimes several feet, to remove unstable topsoil and reach a compact, solid subsoil. This trench would then be filled with layer upon layer of different-sized stones, starting with large rocks at the bottom for drainage, followed by progressively smaller gravel, and finally a layer of packed clay or sand. This created a stable, well-draining base that acted like a modern roadbed, preventing the ground from shifting with the freeze-thaw cycles of the high altitudes or turning to mud during heavy rains. Only after this foundation was perfectly set would the final surface be applied. In the most important sections, this meant a pavement of tightly fitted cobblestones, laid with the same precision seen in their finest walls. These stones were not just thrown down, they were often selected for their flat shapes and carefully arranged to create a relatively smooth, interlocking surface that could withstand the relentless traffic of llama caravans and thousands of marching feet. But travel down from the mountains to the vast coastal deserts and the road transforms. Here, the challenge was not too much water, but a crushing lack of it. The ground is often loose, shifting sand, which provides a terrible surface for travel. The Inca solution was as clever as it was simple. They used the earth itself as a binding agent. In these arid regions, crews would often mix the native sand with clay and water to create a form of natural cement. When compacted, this mixture would harden into a firm, almost concrete-like surface that could resist the wind and remain stable for caravans. In some of the driest areas, they even built raised causeways, constructing low walls on either side of the path and filling the center with this stabilized earth. These walls served a dual purpose. They clearly defined the route across featureless stretches of sand that could easily obscure a trail, and they also helped to contain the road surface, preventing it from being scattered by the desert winds. This attention to local material science shows a profound adaptability. They weren't just building a road, they were crafting a surface in dialogue with the very chemistry of the soil. Perhaps the most telling feature of this thoughtful engineering is something you can still see today: the central gutter. On many well-preserved highland sections, running directly down the middle of the road, is a single, continuous line of stones set slightly lower than the pavement on either side. This was not an accident or a decorative feature, it was a deliberate drainage channel. This central gutter ensured that any rainwater that fell on the road would be channeled away efficiently, flowing downhill without eroding the walking surfaces on either side. It's a small detail, but it speaks volumes about the long-term vision of the engineers. They were building for permanence, anticipating centuries of Andean storms and designing a system that would protect their investment with elegant efficiency. Walking on such a surface, a traveler would have felt the supreme confidence of Inca engineering, a firm, dry, and reliable path that promised safe passage, whether they were a messenger sprinting against time or a farmer leading a train of sure-footed llamas towards the great city of Cuzco. Now imagine standing on a mountainside where the natural slope is so severe that simply walking across it would be a treacherous effort. The Incas faced this challenge constantly, and their response was to fundamentally reshape the terrain itself. They did not merely lay a path upon the unstable earth, they constructed massive, terraced embankments that created entirely new, level platforms for the road to rest upon. These were not simple piles of rock, they were engineered landscapes, monumental feats of earthworks that turned precarious inclines into stable, reliable thoroughfares. The process began with a huge investment of labor, as workers would cut into the hillside, carving out a wide bench. But instead of just leaving a raw, exposed soil face that would inevitably slump and collapse, they would build a colossal retaining wall to hold everything in place. This wall was the key to the entire structure, a strong, vertical spine that resisted the immense, constant pressure of the mountain pushing against it. The road surface was then built on top of this newly created, perfectly level terrace. In effect, the Incas weren't just building a road, they were building the very ground the road would travel on, demonstrating a willingness to undertake staggering amounts of work to achieve geometric perfection and long-term stability. The true genius of these structures lies in the stonework itself. The Incas perfected a technique known as dry stone masonry, which sounds simple but required an almost supernatural level of skill. The term dry stone means precisely that no mortar, no cement, no adhesive of any kind was used to hold the stones together. The stability of a wall weighing hundreds of tons relied entirely on the precise shaping and placement of each individual block. Stonemasons would spend days, perhaps weeks, working on a single stone. Using harder stone hammers and bronze tools, they would peck, grind, and polish a block of andesite or granite until its faces were perfectly flat and its edges were sharp, creating complex, multi-angled shapes that could interlock with their neighbors like a three-dimensional jigsaw puzzle. The goal was to achieve such a tight fit that the stones would grip each other through friction and gravity alone. The most famous examples of this are the iconic walls in Cusco, where the stones fit so perfectly that the seams between them are virtually invisible, but the same principle, applied on a sometimes even larger scale, was used for the massive retaining walls that braced the Qhapaq Ñan. This meticulous construction method was not just for show, it was a brilliant engineering solution to the Andes' greatest natural threat, earthquakes. A mortar-bound wall is rigid. When the ground shakes during a tremor, that rigidity becomes a fatal weakness, causing the structure to crack and collapse. An Inca dry stone wall, however, is dynamic. During an earthquake, the individually shaped stones in a well-built retaining wall can shift and settle slightly against one another, absorbing and dissipating the seismic energy. The wall essentially dances with the earthquake, moving as a flexible unit and then settling back into place once the shaking stops, often with little more than a few stones slightly repositioned. This seismic resilience is a primary reason why so many of these walls are still standing after 5 centuries in one of the most seismically active regions on Earth. They were designed not just to hold back Earth, but to withstand the very movements of the planet. Beyond their sheer structural strength, these retaining walls served a critical, hidden function: water management. The Incas understood that the silent enemy of any earth-filled structure is hydrostatic pressure. If water seeps into the soil behind a wall and becomes trapped, it turns the earth into a heavy, liquid mass that exerts enormous pressure, inevitably causing the wall to bulge and fail. The dry stone construction cleverly solved this problem. The tiny, intricate gaps between the perfectly fitted stones acted as a natural drainage system. They allowed groundwater to weep through the wall slowly and continuously, preventing it from building up behind the structure. This kept the retained soil dry and stable, eliminating the destructive force of hidden water. It's a principle that modern engineers replicate with deliberate weep holes in concrete walls, but the Incas achieved it simply through the exquisite precision of their craft. The wall itself was its own drainage system. The visual impact of these structures on the landscape was profound. A well-constructed Inca retaining wall does not look like an alien imposition on the mountainside. Instead, it appears to grow organically from the terrain, its stones often matching the local bedrock in color and texture. The lines of the wall frequently curve to follow the natural contours of the hill, creating a harmonious blend of human geometry and natural form. In many places, these walls are so well integrated that they look like ancient, natural stone terraces. This aesthetic was likely intentional, reflecting a worldview that saw humanity as a part of the natural order, not separate from it. By building these monumental walls, the Incas were not conquering the mountain. They were entering into a dialogue with it, using their profound understanding of stone and soil to create a partnership that would endure for millennia. Walking along a section of road supported by such a wall, a traveler was surrounded by more than just engineering. They were witnessing a philosophy carved in stone, a testament to the belief that the most enduring structures are those that respect and work with the immutable forces of nature. Yet this meticulously engineered road, with its perfect stones and swaying bridges, would have been a brutal, unforgiving trail without a final, crucial element, a network of rest. Imagine a chasqui runner having sprinted his leg of the relay in the thin, cold air, his lungs burning, or an imperial official having walked for hours along a high mountain pass, the sun beginning to dip below the peaks. Where could they find shelter, a warm meal, or a safe place to sleep in such a vast and often empty landscape? The answer lay in the Tampus, a system of waystations that transformed the Qhapaq Ñan from a mere path into a supported journey, effectively creating a string of logistical oases across the empire. These were not simple rest stops, they were the vital nodes that powered the entire system, the empire's command and control centers in miniature. Strategically placed at intervals of approximately 12 to 15 miles, a distance considered a standard day's walk for a person or a llama caravan, the Tampus ensured that no traveler on official business was ever left exposed to the elements or far from aid. The sophistication of a Tampus could vary dramatically depending on its location and importance. A small, remote station high in the mountains might consist of just a few simple stone buildings, a rectangular barracks for travelers to sleep in, a corral for the llamas, and perhaps a small storehouse. Yet even these modest outposts were lifelines. The storehouse or kolka was the key feature. These were not barns filled with random supplies. They were meticulously managed state warehouses, pre-positioned with the exact resources needed in that specific region. In a high-altitude tambo, this might mean stocks of dried potatoes chuño, freeze-dried meat chasqui, and warm clothing made from alpaca wool. In a coastal station, the supplies would be entirely different: dried fish, maize, and fresh water. This system of localized provisioning was a stroke of logistical genius. It meant that an army on the move or a traveling administrator did not have to carry weeks of supplies with them, drastically increasing their speed and range. The state, through the mita labor system, would collect these goods as tribute from local communities and then redistribute them along the road network, creating a flow of resources that followed the needs of the empire. At major crossroads or near important administrative centers, however, the Tampus could evolve into small, bustling complexes, more like imperial service plazas than simple inns. These larger establishments, sometimes called royal Tampus, could include separate accommodations for nobility, larger storage facilities, and even areas for craft production to repair equipment or rescue llamas. They became hubs of activity, places where information from different parts of the empire would converge, where caravans from the coast would meet those from the highlands to exchange goods. The official in charge of such a tambo was a person of significant responsibility, tasked with managing supplies, overseeing the chasquis, and providing hospitality to important state personnel. In a very real sense, these larger tambos were the physical embodiment of the state's presence in the provinces, a constant reminder of the Qhapaq Inca's power and his ability to provide for those who served him. For the chasqui runners, the tambo was the very engine of their incredible speed. As we discussed, these relay stations were spaced much closer together for the messenger system, often just a mile or two apart. For the waiting chasqui, the tambo was a place of tense anticipation. He would spend his shift there, staying warm, eating, and remaining in a state of constant readiness for the sound of the conch shell trumpet from the approaching runner. The handoff itself was a blur of focused efficiency: the arrival, the transfer of the quipu or the memorized message, and the immediate departure of the fresh runner. The entire system was designed to eliminate downtime. The message never slept, it only moved, propelled forward by a human chain of endurance that was supported at every link by the shelter and supplies of the Tambo network. This system allowed the Inca state to achieve a velocity of communication that was unmatched in the pre-industrial world, and it was the humble Tambo that made it all possible. The presence of these waystations also had a profound social and economic impact on the surrounding region. While the Tambos themselves were state-owned and operated for official use, their existence often spurred the growth of small, ancillary settlements. Local communities would sometimes spring up nearby to provide services or goods to the Tambo staff and the passing traffic. This created a ripple effect, integrating remote areas into the broader economic sphere of the empire. Furthermore, the mita labor obligation extended to staffing and maintaining the Tambos. People from nearby villages would take turns serving as caretakers, cooks, or guards, which meant that a significant portion of the population had a direct personal connection to the functioning of the road. This wasn't a distant, abstract government project. It was a system that involved their labor and, in return, offered them protection and a tangible link to the power and prestige of Cusco. The Tambo, therefore, was more than just a building. It was a social institution, a place where the abstract concept of the empire became a daily, lived reality for thousands of people, binding them ever closer to the central state through the simple, essential acts of providing shelter and sustenance. But for all the brilliance of the stones and bridges, the Qhapaq Ñan was ultimately a system powered by people. Its true speed and efficiency came not from the path itself, but from those who ran upon it, the chasquis, the elite relay runners who were the human heartbeat of the empire. These were not ordinary messengers, they were the imperial equivalent of Olympic athletes, selected from a young age for their exceptional speed, endurance, and lung capacity, a vital trait in the thin air of the high Andes. From their early teens, they underwent rigorous training, learning to sprint at altitude, to navigate the treacherous stone stairways with unerring footing, and to memorize complex messages with perfect accuracy. Their entire lives were dedicated to one purpose: moving information faster than anyone thought possible. The system they operated was a masterpiece of logistical planning, a relay designed to eliminate fatigue as a factor. Along the main roads, small stone structures called chasqui or messenger houses were built at intervals of roughly 1 to 2 miles, a distance a fit runner could cover at a dead sprint. Inside each house, 2 or more chasquis were always on duty, maintaining a state of constant readiness. The system operated with the precision of a Swiss watch. As a runner approached the next station, he would blow a quipu-tied, a trumpet made from a conch shell, its distinctive wail echoing through the mountain passes. This sound was the signal for the waiting chasqui to spring into action. He would run out to meet the incoming runner, and without breaking stride, the message would be transferred. This handoff was the critical moment. The fresh runner, his muscles warm and his breath steady, would immediately launch into his own sprint towards the next station. The previous runner, his duty complete, could then rest and recover. In this way, the message itself never stopped moving. So what exactly was being carried so frantically across the empire? The chasquis were responsible for 2 types of information. The first, and perhaps most fascinating, was the quipu. This was not a simple rope with knots. It was a sophisticated, coded recording device made of a main cord from which hung numerous subsidiary strings of different colors. The position of the knots, the type of knots, and the colors of the strings all conveyed specific information. While the exact code remains a subject of intense scholarly debate, it is widely believed that quipus could record numerical data like census counts, tribute records, and warehouse inventories. Some researchers even suggest they could log more narrative information, perhaps serving as a mnemonic device for complex messages. The chasqui would carry this physical object, this tangible piece of state data, ensuring its secure passage. The second form of communication was the memorized oral report. For urgent or sensitive messages that were not suited to the quipu's format, a chasqui would commit the information to memory. This required incredible mental discipline. He might be tasked with memorizing a specific command from the Sopa Inca to a provincial governor, a detailed report on a rebellion, or the outcome of a distant battle. The accuracy of this oral transmission was paramount. There was no room for error or personal interpretation. To ensure this, it is believed that messages were often delivered in a standardized rhythmic chant or song, a technique that aids memorization and reduces the chance of mistakes. This combination of the tangible quipu and the memorized speech gave the Inca state a flexible and incredibly secure communications network. Sensitive information stayed locked in a runner's mind until it was delivered directly to its intended recipient, while quantitative data was preserved in the intricate knots of the quipu. To appreciate the sheer velocity of this system, consider the numbers. A single chasqui running in the relay fashion was part of a machine that could cover an astonishing 250 miles in a single 24-hour period. This means a message could travel from the capital, Cusco, to the far northern capital of Quito, a distance of over 1,200 miles, in less than a week. This was a speed of communication that would not be surpassed in the Andes until the arrival of the telegraph in the 19th century. It granted the Inca emperor a strategic advantage that was almost magical to his rivals. He could learn of events happening on the farthest borders of his empire and issue commands in response before local chieftains could even consolidate their gains. This incredible flow of information is what made the empire not just large, but truly unified and responsive, a living organism connected by the pounding footsteps of its chosen runners. But a system this vast and complex required more than just fast runners. It demanded a reliable method for recording and transmitting information with perfect accuracy. This brings us to one of the most enduring and fascinating mysteries of the Inca civilization, the quipu. To our modern eyes, a quipu looks deceptively simple, a collection of colored cords hanging from a main string with a series of intricate knots tied along their length. For a long time, Western scholars dismissed them as primitive tallying devices or, at best, crude mnemonic aids, but we now understand that the quipu was something far more sophisticated. It was the administrative backbone of the empire, a complex three-dimensional data storage system that allowed the Incas to manage their vast domain without ever developing a system of writing as we know it. At its most basic functional level, the quipu was an extraordinarily efficient accounting tool. Imagine the immense logistical challenge of running Tawantinsuyu. The state needed to keep track of everything: the number of taxpayers in a province, the volume of potatoes stored in a mountain warehouse, the count of llamas in a royal herd, the size of an army on the move. The quipu was the solution. Each element of its design carried specific meaning. The color of the cord was its primary classifier. A brown cord might represent potatoes, a white cord could signify silver, and a red cord might denote soldiers. The position of the knot on the cord indicated the order of magnitude knots at the bottom representing units, then tens, hundreds, and so on, ascending the string. The type of knot itself conveyed the number. A figure 8 knot might represent the number 1, while a long knot with a specific number of turns could represent 2, 3, or 4. A single quipu could thus hold a vast amount of numerical data, neatly organized and easily transportable by a chasqui runner. The true genius of the system, however, lay in its hierarchical structure, which mirrored the organization of the empire itself. The main horizontal cord acted as the central authority. From it dangled primary pendant cords which could represent major categories like an entire province. From those primary cords, secondary cords might hang, representing individual villages within that province. And from those, even smaller cords could specify particular families or resources. A skilled quipu reader, known as a quipu-tied, could read this structure like a modern database administrator navigates a spreadsheet, drilling down from the general to the specific. He could look at a quipu and see not just that the empire had 10,000 bushels of maize in storage, but that the province of Tawantinsuyu held 5,000, the province of Tawantinsuyu held 3,000, and the province of Qhapaq held 2,000. This granular level of detail gave the Qhapaq Inca and his administrators an unprecedented, real-time overview of the entire empire's wealth and manpower. But this is where the mystery deepens and where modern research is pushing the boundaries of our understanding. While the numerical function of quipus is well established, there is tantalizing evidence that some quipus may have recorded information far beyond simple numbers. Spanish chroniclers from the 16th century left intriguing accounts. They reported that quipus were used to record history, laws, and even poetry. They described how quipu-tied would recite the information stored on the cords, sometimes delivering long, complex narratives that had been passed down through generations. This suggests that the quipu may have served as a sophisticated mnemonic device, where the combination of colors, not types, chord materials, and even the direction of the twist in the string served as triggers for memorized stories. The physical object was not the story itself, but a key that unlocked a vast oral tradition stored in the memory of a trained expert. The tragic consequence of the Spanish conquest was the deliberate destruction of this knowledge. The colonists, seeing the quipu as a tool of pagan idolatry and a symbol of the old order, systematically sought out and burned quipus and executed the quipu-tied. In doing so, they effectively shredded the archives of the Inca Empire and silenced the librarians who knew how to read them. Today, scholars are like cryptographers trying to crack a code without the key. They use statistical analysis, comparing the structures of hundreds of surviving quipus to look for patterns. They study colonial documents that describe quipus in use. And they work with contemporary communities in the Andes who have preserved a tradition of knot-making, searching for clues that might unlock the narrative potential of these ancient devices. It is a painstaking puzzle, and the full story of what the quipu could truly record may be lost to time. For the Qhapaq Ñan, however, the quipu's role was immediate and indispensable. It was the perfect technology for the road. A quipu was lightweight, durable, and could hold a massive amount of data in a small, portable package. A chasqui runner could easily carry one as he sprinted between tambos. At each station, the information could be quickly verified and passed on. This allowed for a continuous flow of data to and from the capital. A governor in a distant province could send a quipu detailing the season's harvest. Military commanders could send updates on troop movements and supplies. The system created a constant, quantifiable feedback loop that allowed the central government to manage resources with an efficiency that would be impressive even today. The road was the physical network that moved people and goods, but the quipu was the informational network that moved knowledge, making the empire not just a territory, but a manageable, responsive state. It was the silent, knotted language of power that kept the heart of Tawantinsuyu beating in rhythm across thousands of miles of mountain and desert. This incredible communication network, however, was not built for messages of peace and trade alone. The ultimate purpose of the Qhapaq Ñan's speed and precision was to project military power, to ensure that the will of the Qhapaq Inca could be enforced anywhere in his empire with breathtaking swiftness. Think of the road not just as a highway, but as the empire's ultimate strategic weapon, a tool that allowed the Incas to move armies with a speed and secrecy that their enemies could not possibly anticipate or counter. In a realm of isolated valleys and formidable mountain barriers, the ability to concentrate force rapidly at a distant point was the key to both conquest and control. The primary military challenge in the Andes was fragmentation. Before the Incas, the region was a patchwork of rival chiefdoms, each nestled in its own valley, protected by the sheer difficulty of the terrain. An army from one valley would have a grueling, slow climb to attack a neighbor, giving the defenders ample warning. The Inca solution was to build a network that operated above and across these natural boundaries. By constructing roads along the high ridges, they created what modern strategists would call internal lines of communication. This meant that Inca forces, starting from a central point like Cusco, could move along the spine of the Andes to reach any troubled province without having to descend into and climb out of every single valley along the way. They could outflank local defenses, appearing where they were least expected, high above the traditional invasion routes. This strategic positioning turned the geography that had once protected local tribes into a liability, as the Incas now held the high ground both literally and figuratively. Speed was the decisive factor. A rebellion might brew in a province 100 miles away. In a pre-road society, news of that unrest would take days to reach the capital, and an army would take weeks to march to the scene, by which time the rebellion could have solidified. But for the Incas, the chasqui system meant the emperor could learn of the uprising within a day or two. Orders could then be dispatched immediately to the nearest military garrison via the same relay runners. Well supplied from the local tambo storehouses, a force of seasoned Inca soldiers could be on the move within hours, marching along a paved road that allowed them to cover 20 miles or more a day, even in the mountains. They could descend upon the rebels with shocking speed, often before the dissidents had finished consolidating their own forces. This rapid response capability acted as a powerful deterrent. Potential rebels knew that the long arm of the Qhapaq Inca could reach them impossibly fast, making the cost of defiance catastrophically high. Secrecy and surprise were equally important components of their military doctrine. The Incas mastered the art of the strategic feint and the hidden approach. The road network provided them with multiple options for moving troops. They could march a large, visible army along a main highway as a diversion, while a smaller, elite force used a parallel or secondary path to approach the target from an unexpected direction. Many of these secondary roads were deliberately built to be narrow and discreet, tucked into folds in the landscape or hidden just below ridgelines to conceal movement from the valleys below. There are accounts of Inca armies using these concealed paths to scale what were considered unscalable cliffs at night, appearing at dawn inside the very heart of a fortified settlement that had believed its mountain defenses were impregnable. This ability to appear as if from nowhere was a psychological weapon as much as a physical one, fostering a belief in the Inca army's near supernatural abilities. The design of the roads themselves often served tactical purposes. In strategically sensitive areas, such as approaches to frontier forts or important passes, the road might be deliberately constructed in a way that channeled potential enemies into kill zones. It could be narrowed to single file width, forcing an attacking force to break its formation, or it might be routed underneath defensive walls where defenders could rain down projectiles. The famous Inca stonework came into play here as well. In some narrow passes, you can still see where the road is flanked by beautifully constructed retaining walls that also functioned as perfect defensive parapets, giving Inca soldiers protected positions from which to fight. Every aspect of the road, from its grand route to the Chinese letter of its construction, was considered through the lens of military utility. It was an infrastructure designed not just for travel, but for domination, ensuring that the empire's soldiers always held the advantage of position, supply, and surprise, making the Qhapaq Ñan the silent, steadfast guarantor of Inca imperial power. Yet for all its military and administrative power, the Qhapaq Ñan served a purpose that reached far beyond the needs of the state and touched the very soul of the empire. These stone pathways were not merely corridors of control, they were spiritual arteries channeling the faith of the people toward the most sacred places in the Inca world. The road was a physical manifestation of a cosmic connection, a means to walk the same paths the gods had traveled and to draw closer to the divine forces that animated the mountains, the sky, and the earth itself. This sacred dimension transformed a journey of obligation into a pilgrimage of profound personal and communal significance. The ultimate destination for many of these spiritual journeys was the city of Machu Picchu. While we often think of it today as a royal estate or astronomical observatory, its location and the challenging path to reach it suggest a powerful role as a pilgrimage center. The journey itself was part of the transformative experience. A pilgrim leaving the capital of Cusco would first descend into the sacred valley, a place of relative warmth and fertility, before beginning the arduous ascent along the stone stairways that climb into the cloud forest. This physical struggle, the thinning air, the relentless climb, the passage through different ecological zones was a form of purification. By the time a pilgrim reached the Intai Pungku, the Sun Gate, and looked down upon the citadel cradled between soaring peaks, they had undergone a physical trial that prepared them for a spiritual encounter. Arriving at Machu Picchu was not like arriving at a normal city. It was to enter a sanctuary deliberately placed in a liminal space between the earth and the heavens, where the architecture itself was aligned with the solstice sun and the surrounding apus or mountain deities. Another focal point of intense devotion was the Island of the Sun in the middle of Lake Titicaca, the body of water revered as the birthplace of the Inca sun god, Inti, and the site where the first Incas, Manco Qhapaq and Mama Oclo, were brought into the world. The pilgrimage to this island was one of the most important in the empire. The final approach was made by reed boat, but the long land journey to the lake shore was conducted along the Qhapaq Ñan. Upon reaching the island, pilgrims would ascend a grand staircase to a sacred complex that included a ceremonial table and a footprint carved into the rock, believed to be that of the sun god. To complete this pilgrimage was to trace the origins of creation itself, to physically stand at the point where the world of the gods intersected with the world of humans. The road made this profound connection possible, linking every corner of the empire to its mythological heart. The act of walking the sacred road was itself a ritual. Pilgrims did not simply travel from point A to point B. They moved through a landscape imbued with spiritual energy. Along the route, they would encounter Huaca's sacred spots that could be an unusual rock formation, a spring, a cave, or a mountain pass. At these huacas, travelers would make offerings. These might be simple, like a coca leaf tossed respectfully onto the ground, or more significant, like a perfectly carved miniature llama made of shell or stone. These offerings were not bribes to the gods, they were acts of reciprocity, a core Inca principle known as Ini. It was a way of giving thanks for safe passage thus far and asking for protection on the journey ahead. The road, therefore, was punctuated with countless moments of quiet devotion, each offering a tiny thread in the vast tapestry of belief that bound the people to their land. This spiritual network was not a separate system from the imperial one. The two were deeply intertwined. The state actively organized and facilitated these pilgrimages. The storehouses or kolkas that lined the routes would have provided food and supplies for pilgrims, just as they did for soldiers and officials. The tambos offered shelter. This state support ensured that the empire's religious narrative, the story of the divine Sopa Inca and the birth of the sun at Lake Titicaca, was physically accessible to its subjects. By making the pilgrimage possible, the state reinforced its own legitimacy. To walk the road to a major huaca was to participate in the state religion, to have the power of the empire and the glory of its gods made tangible with every step. The road was a tool of spiritual integration, ensuring that a farmer from the coast and a herder from the highlands shared a common set of sacred experiences and destinations, fostering a unified cultural identity across immense distances. In this light, the Qhapaq Ñan becomes more than an engineering marvel. It reveals itself as a profound expression of the Inca worldview. For the Incas, the concept of Pacha encompassed the entire universe, a unified whole where the human, natural, and spiritual realms were inseparable. The road did not cut through this unity, it wove it together. It was a physical line connecting the practical needs of an empire to the spiritual needs of its people, the political authority of Cusco to the mythological power of Lake Titicaca. A message runner was not just a civil servant, he was a courier moving through a sacred landscape. A stone staircase was not just a functional ascent, it was a pathway leading pilgrims closer to the Apus. This holistic vision is perhaps the most enduring legacy of the Inca roads. They show us that the most powerful infrastructure is not that which simply moves people and goods, but that which connects a society to its deepest beliefs, transforming a network of stone into a pathway for the human spirit. Beyond the swift passage of soldiers and the urgent whispers of messengers, the Qhapaq Ñan pulsed with a more constant, life-sustaining rhythm, the steady flow of goods that nourished the empire. These stone pathways were the economic arteries of Tawantinsuyu, a vast circulatory system that moved the incredible diversity of the empire's resources from where they were produced to where they were needed. This was not a simple free market trade, it was a meticulously managed state economy, and the road was the engine that made it all possible, transforming geographical abundance into centralized power. The sheer variety of goods moving along these routes was a direct reflection of the empire's ecological reach. From the arid Pacific coast, caravans of llamas would carry dried fish, packed in large baskets, and precious spondylus shells, which were revered for their vibrant orange color and used in rituals and royal ornaments. They brought up fruits like lucuma and avocados grown in the sun-drenched coastal valleys. Ascending into the high Andes, the cargo shifted dramatically. Here, the mainstays were the incredible diversity of potatoes and other tubers, which could be freeze-dried into chuño to last for years, and grains like quinoa. Llama wool and the even finer alpaca and vicuña wool, essential for making the fine textiles that were a mark of status and wealth, were transported from the high-altitude pastures. From the steep eastern slopes of the Andes, the Antasullu region, came exotic goods that were as valuable as they were rare: brightly colored parrot and macaw feathers for headdresses, jaguar pelts, medicinal plants unknown in the highlands, and coca leaves, a sacred and vital stimulant for coping with the harsh altitude. The road allowed these distinct ecological zones to specialize, creating an internal economy of breathtaking complexity where the desert, the mountain, and the jungle were all connected in a single, interdependent system. This movement of goods was fundamentally driven by the Inca system of tribute known as the mita. Unlike a tax paid in currency, the mita was a labor obligation owed to the state. Every household across the empire was required to contribute a certain amount of work each year on state projects, building temples, maintaining irrigation canals, or, most critically, working the state's own extensive agricultural land. A portion of the harvest from these state farms, along with goods produced by specialist artisans who also served their mita, became the property of the central government. This wealth was then collected and transported along the Qhapaq Ñan to massive state storehouses or kolkas, strategically located near administrative centers and along the road itself. Imagine a continuous, slow-moving river of wealth flowing toward the capital. A village in the highlands might pay its tribute in sacks of chuño. A community on the coast might contribute bales of dried cotton. This system allowed the state to amass enormous surpluses, which were not hoarded but strategically redistributed. The ultimate destination for the most prized goods was Cusco, the navel of the world. The city was not just a political capital, it was a spectacular display of the empire's bounty. Here, the Sapa Inca and the royal Panoca, or lineage, consumed the finest products of the realm. The royal warehouses would have been overflowing with the best textiles, the most exotic feathers, and the most perfectly preserved foods. This concentration of wealth in the capital served multiple purposes. It supported the nobility and the state religion, funding the construction of magnificent temples and the elaborate ceremonies that reinforced Inca divine authority. It also allowed the state to act as a great benefactor. During festivals or in times of local famine, the state could redistribute food and goods from its storehouses to the people, a powerful demonstration of the Qhapaq Inca's generosity and the tangible benefits of belonging to the empire. The road ensured that this system of reciprocity worked, that the tribute flowed in and the blessings flowed out, binding every community to the center through a continuous exchange of obligation and reward. The logistics of this economic machine was staggering. At the heart of it all was the llama, the only beast of burden in the Americas. A single llama can carry a load of about 60 to 70 pounds. Therefore, moving large quantities of goods required immense caravans, sometimes consisting of hundreds of animals. These caravans were managed by specialized drivers who knew the rhythms of the road and the needs of their animals. The journey was slow and deliberate, dictated by the pace of the llamas. This is where the Tambo waystations proved their worth again. They provided not just shelter for the drivers, but crucially, corrals for the animals and fodder stored in the kolkas. The state's foresight in prepositioning supplies along the route meant that these caravans did not have to carry all their own food, making them more efficient. The entire system was recorded and managed with the quipu. As a caravan arrived at a depot, quipu-tied would carefully record the incoming tribute, the type of good, the quantity, and its origin by tying knots on the colored cords. This created a vast, decentralized accounting system that gave administrators in Cusco a real-time picture of the empire's wealth. They could see which regions were productive, which were falling short, and where supplies needed to be sent. The Qhapaq Ñan, therefore, was more than just a physical road. It was the backbone of the first great command economy in the Americas. It enabled a level of economic integration and central planning that would not be seen again in the region for centuries, proving that the true power of the empire was not just in its armies, but in its ability to harness the land itself and deliver its riches to the seat of power. And yet, in a twist of historical fate as cruel as it was decisive, the very system that gave the Inca Empire its strength would become the instrument of its unraveling. The Qhapaq Ñan, designed to speed Inca armies to the frontiers, would instead carry a foreign enemy directly to the empire's heart with a velocity that left the Incas reeling. When Francisco Pizarro and his small band of conquistadors landed on the shores of Peru in 1532, they did not arrive to a disorganized wilderness. They stumbled upon a sophisticated network of power, and they immediately understood that the roads were the key to exploiting it. Unlike the Spanish explorers who had to hack their way through jungles in other parts of the Americas, Pizarro's men found a clearly marked, well-maintained highway system that led them unerringly inland, directly toward the centers of Inca power. The empire, for all its internal strength, had inadvertently built the perfect invasion route for its own conquerors. The timing could not have been more catastrophic for the Incas. The empire was in the throes of a devastating civil war between two brothers, Atahualpa and Huascar, both sons of the late Emperor Huayna Qhapaq, who had died from a disease likely introduced by earlier European contact. This war was not a minor skirmish. It was a massive, empire-wide conflict that had drained the treasury, exhausted the armies, and bitterly divided loyalties. The very roads and chasqui system that should have reported the Spanish arrival with lightning speed were instead clogged with the urgent traffic of war messages about troop movements, battlefield outcomes, and the shifting allegiances of provincial governors. The Spanish, a bizarre and seemingly minor threat, were initially seen as a curiosity or a peripheral concern compared to the existential struggle for the throne. This internal fracture provided Pizarro with the perfect cover, allowing his tiny force to move with a freedom they never would have enjoyed in a unified, vigilant empire. Pizarro, a man of limited education but immense cunning, quickly grasped the strategic advantage the roads offered. He realized that the same principle that allowed the Incas to project power, speed along internal lines, could be used against them. He did not wander aimlessly. He purposefully followed the main coastal road, the Tawantinsuyu Road, which led him toward the important highland city of Qhapaq. Along the way, the Spanish witnessed the efficiency of the Inca infrastructure firsthand. They marveled at the tambos that provided them with unexpected shelter and saw the storehouses filled with supplies they could plunder. They observed the chasqui runners, though the messages they carried were now about a war the Spanish intended to exploit. Most importantly, the road allowed Pizarro to bypass the difficult, time-consuming work of exploration and navigation. He was on a guided tour of the empire's vulnerabilities, conducted on a paved highway. The absolute masterstroke of this strategy was the capture of the Inca Atahualpa at Qhapaq. After his victory in the Civil War, Atahualpa was encamped near the city, resting with his massive army of tens of thousands of seasoned troops. Confident in his power and likely viewing the fewer than 200 Spanish as an oddity rather than a threat, he agreed to meet Pizarro in the main square of Qhapaq. What happened next is one of history's most stunning acts of audacity. The Spanish, hidden in buildings surrounding the square, launched a surprise attack with cavalry, firearms, and steel swords against Atahualpa's largely unarmed retinue. The shock of this assault, the like of which the Incas had never witnessed, caused panic. Thousands were slaughtered in a matter of hours, and Atahualpa himself was taken prisoner. The speed of this decapitation strike was only possible because the roads had allowed Pizarro to reach the emperor's doorstep with such efficiency. The very network that should have delivered a warning to Atahualpa instead delivered his captors. From that moment, the Qhapaq Ñan became a Spanish possession. With the Sapa Inca as their hostage, the conquistadors gained de facto control over the empire's communication system. They could now send orders in Atahualpa's name, and thanks to the chasquis, those orders would be obeyed with the same unquestioning speed as before. The gold and silver ransom for Atahualpa, a treasure of legendary proportions, was gathered from every corner of the empire and transported to Qhapaq along these same roads. Later, when the Spanish marched on the capital of Cusco, they did so along the magnificent Tawantinsuyu Road, the royal highway itself. They met little organized resistance as the empire was still leaderless and in shock from the capture and subsequent execution of Atahualpa. The Incas' greatest creation, the stone web that bound their world together, now served to tighten the chains of their own subjugation. A heartbreaking testament to the fact that even the most brilliant tools are only as strong as the unity and wisdom of the hands that wield them. The legacy of the Qhapaq Ñan is far from a forgotten relic. It is a living presence etched into the very bones of the Andes, waiting for modern travelers to walk in the footsteps of history. While the empire that built it has long since fallen, the roads themselves, in a stunning testament to their engineering, have refused to vanish. Today, you can still trace their path from remote, windswept highlands to lush cloud forests, offering a tangible connection to the Inca world that is unparalleled in the Americas. The most famous and frequently traveled section is without a doubt the Inca Trail to Machu Picchu. For the thousands who hike it each year, it is more than just a scenic route to a famous ruin. It is a 4-day immersion into Inca engineering. The journey is a museum without walls where you physically interact with the legacy. You climb the original stone staircases, your breath shortening just as the chasquis did. You pass through ancient tambos, their walls still standing after centuries. You traverse mountainside paths so perfectly engineered that they feel secure even on the steepest slopes. Arriving at the Sun Gate at dawn and seeing Machu Picchu laid out below is the climax, but the true magic of the experience is the road itself. The realization that you have approached the sacred city exactly as the Incas intended, having undergone a physical pilgrimage that transforms a visit into an experience. But the story of the Qhapaq Ñan extends far beyond this single, well-trodden path. The empire's backbone stretches across 6 modern South American countries, and in many places it survives in astonishingly pristine condition, often far from the tourist trail. In Peru, sections of the Highland Road, the true Qhapaq Ñan, can be hiked in the breathtaking Cordillera Blanca, where the stone-paved path snakes between glacial peaks over 20,000 feet high. In Bolivia, near Lake Titicaca, you can walk along raised causeways that cut across the Altiplano, the vast, high-altitude plain, with the blue expanse of the sacred lake on one side and the snow-capped Cordillera real on the other. In Ecuador, stretches of the road weave through Paramo grasslands, and in Chile and Argentina, the southernmost extensions can be found, testament to the empire's vast reach. What is remarkable is how these paths continue to be used. In many rural Andean communities, the Inca Road remains the primary route to the next village for taking goods to market or for herding llamas and alpacas. For these communities, the Qhapaq Ñan is not an archaeological site. It is a part of their daily lives, a functional piece of infrastructure that has served their ancestors for hundreds of years. This continuous use is the highest compliment to the original engineers, whose work has remained relevant for half a millennium. Recognizing this incredible global value, the United Nations Educational, Scientific and Cultural Organization, UNESCO, designated the Qhapaq Ñan as a World Heritage Site in 2014. This was a landmark decision and a uniquely complex one. Unlike a single cathedral or palace, this was a serial nomination, encompassing hundreds of individual archaeological sites across thousands of miles. The designation acknowledges the road not just as a collection of stones, but as a masterpiece of human creative genius and a testament to the power of the Inca state. This international recognition was a crucial step, providing a framework and impetus for preservation on a multinational scale. The status helps secure funding, promotes scholarly research, and raises global awareness about the road's significance, encouraging sustainable tourism that benefits local communities while protecting the fragile remain. The work of preservation, however, is a constant and delicate challenge. The primary threats are both natural and human. The Andes are a geologically active and climatically harsh environment. Earthquakes, landslides, and relentless weather patterns continuously test the ancient masonry. More pressingly, modern development poses a significant risk. New roads, mining operations, and the expansion of agriculture can easily cut across and destroy unprotected sections of the Qhapaq Ñan. Preservation efforts are therefore a race against time, requiring a collaborative approach. National governments, international organizations, and local communities are all essential partners. Archaeologists and conservators work carefully to stabilize retaining walls and clear drainage canals, using traditional techniques that honor the original construction methods. They document every stone, creating detailed maps that will guide future efforts. Perhaps the most important aspect of modern preservation is the involvement of the descendant communities, the men and women whose ancestors built these roads. Their knowledge of the land is irreplaceable. They often know of sections of the road that are not on any official map, and they understand the seasonal patterns of water and erosion that threaten it. By involving these communities as partners, as guides, as guardians, and as decision-makers, preservation projects become more than just technical exercises. They become acts of cultural revival. This collaborative spirit ensures that the Qhapaq Ñan is not simply frozen in time as a museum piece, but is understood as a living part of Andean heritage, a symbol of resilience and ingenuity that continues to inspire. To walk these roads today is to witness a dialogue between the past and the present, where the enduring stones of the Incas meet the enduring spirit of the people who still call these mountains home. When we think of history's great road builders, one civilization inevitably springs to mind first: the Romans. Their legendary network, stretching from the damp mists of Britain to the sands of the Middle East, stands as an enduring symbol of imperial might. It's a natural comparison to make, placing the Qhapaq Ñan alongside the Roman roads, but the exercise reveals less about which was superior and more about how two vastly different cultures, separated by an ocean and millennia, arrived at brilliant engineering solutions uniquely tailored to their worlds. The Romans built roads to conquer geography. The Incas built roads to harmonize with it. The fundamental difference lies in the very purpose of each network. Roman roads were, first and foremost, military instruments designed for the rapid deployment of legions. They were built to facilitate conquest and then to secure it, enabling heavily armed soldiers to march 25 miles a day on a predictable, stable surface. This military imperative demanded straightness. Roman surveyors aimed for direct lines, famously bulldozing through obstacles, building massive embankments, and tunneling through hills to maintain an arrow-straight path. This was a declaration of power, a statement that the Roman will would not be deterred by the whims of the landscape. The resulting roads, with their deep, multi-layered foundations and cambered surfaces for drainage, were engineered for heavy, wheeled traffic, for carts laden with supplies and for the wagons of trade that followed the eagles. The Roman road was a platform for the wheel, a technology central to their economy and warfare. The Inca approach was the photographic negative of this philosophy. Their world was one of verticality, of mountain ranges that defied straight lines and terrain where the wheel was impractical. The primary traffic on the Qhapaq Ñan was pedestrian, armies on foot, llama caravans, and sprinting chasqui messengers. This purpose shaped the road's very soul. Instead of fighting the topography, Inca engineers embraced its contours. Their roads snake and zigzag, following the natural spine of the land, not out of a lack of planning, but as a profound adaptation to it. Where the Romans saw an obstacle to be overcome, the Incas saw a feature to be incorporated. A massive, immovable boulder wasn't blasted aside, the road simply curved gracefully around it. This resulted in a network that feels organic, a pathway that seems to have grown from the mountain itself rather than being imposed upon it. The contrast in materials and construction methods is equally stark, born from the distinct resources available to each empire. Roman engineering is synonymous with concrete, mortar, and the precise cutting of stone blocks. Their roads were monumental, layered constructions, a trench filled with rubble, a layer of sand, then stones set in mortar, and finally a surface of large, tightly fitted paving stones. This created an incredibly durable, rigid structure that has, in many places, survived 2,000 years of European history. It was a high-energy, high-tech solution for its time, leveraging the empire's vast resources and sophisticated material science. The Incas, working with a Bronze Age toolkit, achieved similar longevity through an almost supernatural mastery of dry stone masonry and an intimate understanding of local forces. Without mortar or concrete, they relied on the perfect shaping of stones. Each block was painstakingly worked to interlock with its neighbors, creating structures that were not rigid but flexible. This was their secret weapon against the earthquakes that frequently shake the Andes. While a mortared Roman wall might crack, an Inca wall could sway and settle during a tremor, then restabilize, its stones gripping each other through friction and gravity alone. Their roads were less about creating a new, artificial surface and more about skillfully enhancing the natural one, paving only where necessary and often relying on carefully prepared and drained earth. It was a low-tech approach that yielded high-tech results through sheer brilliance of design. Perhaps the most telling comparison lies in how each empire dealt with its greatest environmental challenge. For the Romans, the primary threat was water from above rain that could turn a dirt track to mud and undermine a roadbed. Their solution was the iconic cambered surface and elaborate drainage ditches designed to shed water quickly and efficiently. For the Incas, the challenge was more complex, water from above, certainly, but also water within the earth. Their greatest innovation was managing hydrostatic pressure and groundwater. Their retaining walls were built to weep, allowing water to seep through the joints and prevent buildup that would cause collapse. They built culverts and canals not just to handle rain, but to redirect the powerful forces of mountain watersheds. Each system was a perfect response to its own environmental context. Ultimately, comparing their legacies is a lesson in perspective. The Roman roads, built for wheels, went on to form the backbone of European commerce and travel for centuries, their routes often still followed by modern highways. They facilitated a kind of connectivity that reshaped a continent. The Inca roads, built for feet and hooves, met the needs of their empire perfectly, creating a cohesive state in the most formidable terrain on Earth. The true measure of their achievement is not in how they compare to Rome, but in the breathtaking fact that they created a system of similar scale and sophistication without the wheel, without iron, and without a written language, using only stone, bronze, and an unparalleled collective will. It stands not as a lesser version of a Roman road, but as a uniquely Andean masterpiece, a testament to a different kind of genius, one that sought not to conquer the mountain, but to join with it in a partnership of stone and spirit. Even with all we have uncovered about the Qhapaq Ñan, its grandeur is matched only by the profound silence that hangs over some of its most fundamental secrets. For all the precision of their stonework and the logic of their routes, the Inca engineers left behind no blueprints, no technical manuals, and no written explanations. They built an empire with organizational genius, yet they chose to encode their knowledge in ways that continue to defy our full understanding, leaving us with tantalizing questions that bring us face to face with the limits of our own historical perspective. One of the most enduring puzzles revolves around the very first step, the survey. How did they achieve such breathtaking accuracy over such impossible distances without any of the instruments we consider essential? We can assume they used simple, effective tools, perhaps long cords for measuring distance, or water-filled troughs to establish level lines, or simple sighting devices made of wood. But the consistent placement of the road along stable contour lines, its perfect adaptation to the landscape's grain, suggests a grasp of principles that feels almost mathematical. Did they possess a sophisticated, unwritten understanding of geometry, one that was passed down through generations of master builders? Could they calculate angles and gradients with a precision that allowed them to plot a course through 100 miles of mountainous terrain and have the two teams, starting from opposite ends, meet in the middle with their sections aligning perfectly? The evidence is there in the stone, a silent testament to a skill we can only partially reconstruct, a reminder that our dependence on written formulas might blind us to the power of knowledge deeply ingrained through practice and observation. This leads to another mystery that captures the imagination of explorers and archaeologists alike, the possibility of roads still waiting to be found. We know the main arteries, the grand trunk roads that connected major administrative centers, but the Incas were masters of strategy and secrecy. Were there secondary paths, known only to chasquis and military units, deliberately hidden from view? Routes that skirted just below ridgelines to conceal movement, or paths that traversed impossibly remote stretches of the Amazonian slope now reclaimed by the jungle? The dense vegetation of the eastern Andes swallows traces of human presence with startling speed. It is entirely plausible that significant sections of the network, perhaps even entire branches leading to unknown ceremonial centers or resource sites, remain shrouded in green, their secrets guarded by the forest. Every modern discovery of a new Inca site, like the ongoing explorations around the Cerro Victoria area in Peru, hints at an empire even more extensive and complex than our maps suggest, reminding us that the Qhapaq Ñan may still have stories to tell that we have not yet begun to hear. But the most profound enigma of all is not one of stone or route, but of mind. How did they coordinate the colossal endeavor of building and maintaining a 25,000-mile system without a single written order? We have the quipu, and we are slowly deciphering its numerical codes, but the chronicles insist it held narrative power too. Perhaps the answer lies not in what was recorded on the strings, but in what was triggered in the minds of the quipu-tied. What if the quipu was not the message itself, but a key, a complex cue that unlocked a vast, memorized library of technical knowledge? A specific combination of knots and colors might have prompted a master engineer to recite the exact construction specifications for a suspension bridge, passed down through an oral tradition of incredible precision. The coordination of thousands of workers through the MITA system may have relied on a shared cultural understanding and a hierarchical command structure so ingrained that detailed written instructions were unnecessary. The real project management software of the Inca Empire was not a tablet of clay, but the collective, trained memory of its people, a living network of knowledge that died with the last quipu-tied, leaving us to wonder at the sheer power of a civilization that could hold an entire infrastructure in its mind. What makes the Inca roads so remarkable to a modern engineer is not just that they were built, but how they were built. In an age where we often rely on heavy machinery, concrete, and steel to force our will upon the landscape, the Incas demonstrate a more elegant and perhaps more wise philosophy. Their approach offers a masterclass in principles that are only now becoming urgent priorities in our own field: true sustainability, hyper-local material sourcing, and a profound collaboration with the natural world. The most striking lesson is their radical use of local materials. The Incas did not have a global supply chain. They could not order steel cables from another continent or import special aggregates for concrete. Instead, they practiced a form of extreme resourcefulness, using what the land provided. This wasn't a limitation, it was an inspiration. On the coast, they mixed desert sand with clay to create hardened causeways. In the highlands, they quarried the very andesite and granite of the mountains they were traversing. And for their most awe-inspiring structures, the suspension bridges, they used a material we would consider hopelessly fragile: grass. By meticulously weaving the tough ichu grass into cables thicker than a man's body, they created structures strong enough to support Spanish cavalry. This teaches us a powerful lesson about re-evaluating what we consider a resource. It pushes modern engineers to look closer to home, to innovate with what is readily available, reducing both the environmental footprint and the energy cost of transportation that plague contemporary megaprojects. It's a shift from seeking universally applied, high-energy solutions to developing context-specific, low-energy ones. This leads directly to the second principle: working with the environment, not against it. Modern engineering has often been characterized by a brute force mentality, leveling hills, straightening rivers, and pouring concrete over any obstacle. The Inca philosophy was the opposite. They saw the landscape not as an adversary to be conquered, but as a partner in the design process. Instead of blasting a straight path through a mountain, their roads snake and zigzag, following the natural contours. This wasn't inefficient, it was brilliantly adaptive. The switchbacks reduced the gradient for travelers and, just as importantly, minimized erosion by disrupting the flow of water. When they encountered an immovable boulder, they curved the road around it. When faced with a sheer cliff, they carved a staircase into it, integrating their structure into the mountain's own skeleton. This respect for the existing topography resulted in a network that has survived centuries of earthquakes and landslides because it moves with the land, not against it. For us today, this is a vital lesson in resilience. In an era of climate change and increasing extreme weather events, building infrastructure that can adapt and flex, like the dry stone walls that dance during an earthquake, is far smarter than building rigid structures that will inevitably fracture under stress. Perhaps their most sophisticated mastery was in the realm of water management. The Incas understood that water is the great destroyer of infrastructure, and their solution was not to block it but to guide it with grace. The entire road system is a web of hydrological intelligence, culverts buried just beneath the surface allowed water to pass under the road. Stone-lined canals running alongside acted as gutters. Even the iconic central gutter found on many paved sections was a deliberate feature to channel rainfall away. Their retaining walls were designed to be permeable, allowing groundwater to weep out slowly and prevent destructive pressure buildup. This proactive, empathetic approach to water is desperately needed today. So much of our modern infrastructure fails during floods because it tries to confront water head-on. The Inca method shows us the power of designing for water's natural behavior, of creating systems that invite water to flow where it wants to go, but in a way that protects the structure. It's a lesson that could revolutionize how we design everything from highway drainage to urban stormwater systems, moving from resistance to accommodation. Underpinning all of this was a long-term perspective that is humbling. The Incas built for eternity. They did not envisage their roads needing replacement in 50 or 100 years. The meticulous, labor-intensive process of fitting stones without mortar, of carving stairways into bedrock, was an investment in permanence. This stands in stark contrast to the planned obsolescence and shorter life cycles that often dictate modern projects driven by budget cycles and immediate political gain. The Incas remind us that the most sustainable and ultimately cost-effective solution is often the one that requires more initial effort but lasts for generations. Their infrastructure is a testament to intergenerational thinking, asking us to consider what we are building today that will still be standing and serving people 500 years from now. Finally, there is the lesson of community-integrated maintenance. The annual rebuilding of the great grass bridges was not a burdensome tax, it was a sacred community ritual, a minka. This practice ensured that the knowledge of construction was not lost but was passed down and practiced by each generation. The community had a direct, tangible stake in the upkeep of the infrastructure they relied on. This created a powerful feedback loop and a deep sense of ownership. In our world, where infrastructure is often outsourced to distant corporations and becomes something abstract to the public, the Inca model offers an alternative. It suggests that the health of our bridges, roads, and water systems is not just a technical problem, but a social one. By involving communities in the stewardship of their own infrastructure, we can foster the kind of care and resilience that no maintenance contract can ever guarantee. The enduring legacy of the Qhapaq Ñan, therefore, is not just in the stones but in the spirit of its creation, a blueprint for building in a way that is harmonious, resilient, and deeply connected to both the land and its people. Now, as we stand in awe of these stone pathways carved into the sky, we must turn from the grand sweep of engineering to the individuals whose hands, backs, and collective will made it all possible. The enduring stones of the Qhapaq Ñan are a monument not to a single master architect, but to the thousands of anonymous workers who transformed the Inca vision into a tangible reality. Who were these builders? They were not slaves in chains, but members of a complex societal system known as the mita, a form of labor tax that was as much a part of the social fabric as it was an engine of imperial construction. Every household across Tawantinsuyu, you owed a certain number of days each year to work on state projects, and building the road was one of the most sacred and vital duties. This meant that the workforce was, in essence, the entire empire itself, a rotating core of farmers, herders, and artisans contributing their sweat to a project that benefited all. The organization of this labor force was a logistical marvel in its own right. The work was not a chaotic free-for-all, but was meticulously planned and delegated through the existing hierarchical structure of the empire. An imperial overseer, perhaps an Inca noble or a trusted local governor, would receive the blueprint for a specific section of road. This plan, likely communicated through oral instruction and perhaps aided by models or quipu records, would then be broken down into manageable tasks. The obligation would be assigned to specific islas or kinship-based communities in the surrounding region. each ilu was responsible for providing a certain number of workers for a designated period. This system ensured a constant, predictable flow of labor without completely depopulating any single village or disrupting the agricultural cycle, as the mita service was typically scheduled around key planting and harvest times. Imagine the scene at a worksite high in the Andes. It would have been a bustling, vibrant community, albeit a temporary one. Workers, both men and women, would arrive from their home villages, often bringing their own tools: stone hammers, bronze chisels, and woven baskets for moving earth. They would set up temporary camps near the construction zone. The work itself was grueling and required a variety of specialized skills. The most physically demanding task fell to the quarrymen, who would identify suitable stone and, using the fire and water technique to fracture the rock, extract massive blocks. Next came the skilled stonemasons, who possessed the almost mystical knowledge of how to shape and fit the stones with such precision. Then there were the laborers who prepared the roadbed, digging down to stable ground and creating the layered foundation of gravel and clay. Teams dedicated solely to transport would move the materials using ropes, levers, and sheer muscle power. The air would have been filled with the rhythmic percussion of stone on stone, the calls of team leaders, and the collective effort of a community working toward a common goal. What is crucial to understand is that this labor, while mandatory, was not seen as pure oppression. The mita system was embedded in the Inca principle of reciprocity, known as Ini. In exchange for their labor, the state provided certain benefits. During their service, workers were fed from the state storehouses and often provided with chicha, a fermented corn beer that was both a dietary staple and a ceremonial drink. More broadly, the state offered security, organized religion, and the infrastructure that facilitated trade and communication, the very road they were building. For many, contributing to a project like the Qhapaq Ñan was a source of pride, a tangible way to participate in the glory of the empire and to honor the Sopa Inca, who was seen as a divine ruler. It was a system that bound the individual to the state through a network of mutual obligation, transforming the abstract concept of an empire into the physical act of moving a stone into place. The sheer scale of human effort is almost incomprehensible. To build just 1 mile of paved road on such difficult terrain, with its deep foundations, retaining walls, and drainage systems, would have required thousands of person-days of labor. When you multiply that by 25,000 miles, the number becomes astronomical. This was not the work of a single generation, but a continuous, multi-generational project that spanned the life of the empire. Fathers would have worked on sections that their sons would later maintain. The knowledge of how to build was passed down not in textbooks but on the job site, from experienced elders to young apprentices. This ensured that the sophisticated engineering techniques, the secret to fitting stones, the art of reading the land for a stable route, were preserved and refined over time. The road, therefore, is a living library of practical knowledge, written not on paper, but in the alignment of its stones and the path of its course, a permanent record of the collective intelligence and enduring spirit of the Andean people. As we bring our journey along these ancient pathways to a close, the true scale of the Inca achievement comes into a final, breathtaking focus. We have walked the stone staircases and traced the routes of the chasqui runners, but the legacy of the Qhapaq Ñan transcends its physical presence. It stands as one of history's most profound examples of what humanity can accomplish through a unified vision and a deep, respectful dialogue with the natural world. This was not an infrastructure of conquest in the traditional sense, but one of integration where the empire wove itself into the very fabric of the Andes, creating a harmony between human ambition and the enduring power of the mountain. The true genius of the Incas was their profound understanding that durability comes from adaptability, not dominance. They did not seek to flatten the mountains or bridge every chasm with immutable stone. Instead, they chose the path of least resistance, crafting solutions that were as flexible and resilient as the landscape itself. The dry stone walls that dance during an earthquake, the grass bridges rebuilt annually by the community, the roads that follow the natural contours of the land. Each of these decisions reflects a philosophy that feels remarkably modern. In an age where we grapple with the environmental costs of our own infrastructure, the Qhapaq Ñan offers a timeless lesson. The most enduring creations are those that work in partnership with the forces of nature rather than seeking to overpower them. It is a legacy that continues to pulse with life, not just in the stones walked by tourists, but in the daily rhythms of Andean communities for whom these paths remain a vital connection to their past and present. The story of the Inca Roads is ultimately a human story, a testament to the power of collective will and the transmission of knowledge across generations. It challenges our assumptions about technology and progress, reminding us that sophistication is not always measured in steel and microchips, but sometimes in the perfect fit of two stones and the wisdom of knowing where to place them. What part of this engineering marvel left you in the greatest awe? Was it the sheer audacity of the suspension bridges, the silent intelligence of the water management, or the incredible speed of the communication network? Share your thoughts in the comments below. If you enjoyed this journey into the calm, enduring mysteries of history, please subscribe to the channel for more explorations into the forgotten wonders of our world.